Now we will see how to develop a code for face detection, eyes detection and lip detection. Lip detection means smile detection. So let's start. First, we will import the important libraries. The most important library here in this code are, first is CV2. CV2 is an open source library and it is basically for computer vision. And second is we are going to import NumPy. NumPy is for numerical Python. Whatever the numerical operations we are going to perform, whatever n-dimensional array we are going to use in this example, so all the operations are carried out with the help of this NumPy package. Run this code. Okay. The next is, now we are going to build a model where we are going to detect face as well as eyes and smile detection. So there are three classifiers which are already there in OpenCV. I'll show you that. So here in OpenCV, there are three classifiers, that is hair cascade eye, hair cascade frontal face default and hair cascade smile. So these three classifiers are present in OpenCV package. For the sake of convenience, I have copy pasted these three classifiers into my current directory. If you want to see the classifiers, go into Anaconda 3, then here in library, then side packages, and here CV2, and in the data. So these are the different pre-trained models which are available in the OpenCV. So now we are going to build a model which will detect the smile of a person, eyes and face. Okay. So I have just copy pasted these three classifier, that is hair cascade smile, hair cascade eye and hair cascade frontal face default. Just copy paste these three classifier into the current directory. Okay. If you just copy paste these three classifier in the current directory, you don't need to provide the path. But if you don't want to keep these classifier in your current directory, then in that case you need to provide the entire path. Okay. Now let's load the classifier. First I'll load face classifier. Here, as my classifier is in the current working directory, so I don't need to provide the entire path. I'll just provide the name of the classifier. So just go here and right click this, and this is the name of my classifier. This is eyes. I want this. Frontal face. Copy paste this. .xml is the extension. Next classifier is eyes. Copy paste the name. .xml. And third is, we are also going to detect the smile of a person. Okay. Now the next step is, we are going to do this face, eyes and smile detection using web camera. So for that, you need to create an object for video capture. So cap is the object which we have created. CV2.video capture is a method, and here you need to pass up argument. If you are doing face detection using video which is already there in your laptop, then you can just provide the name of file here. But if you are using your inbuilt camera of laptop, then type 0. If there is some second camera, then type 1. In this way, you can provide different arguments. For now, I am using inbuilt camera of my laptop. That's why I have written 0. So this is the third step where you are going to initialize, in simple terms, camera. Now next step is we want to take the video frame by frame. For that, we will first create a while loop, and 1 stands for this loop is true till the end of video, till the end of the program. And here I am going to read the video capture. So cap.read reads till the end, and it reads frame by frame. Now after reading the video, after reading the frames, the next step is I am going to convert it into a grayscale. Gray is equal to cv2 dot cvt color, and here you can pass two arguments. First is the name of frame, this is the frame video input, and second parameter is you need to pass the code conversion. Here I am converting this to gray, so the code is color underscore dgr to gray. Okay, so with the help of this line, the image will be converted to grayscale. Now first we will perform face detection. For face detection, there is method which is classifier. Classifier is face, right? Our face classifier is in this variable, that is face. So write face dot detect multiscale, and here we pass the argument, that is the name of name or the variable of our video plus scaling factor, and we provide the number of neighbors. You can change this value as per your convenience. Then we are going to create one for loop, and we are going to draw a rectangle when we detect a face. Okay, so for x, y, w and h. Now x for horizontal axis, coordinate on horizontal axis, coordinate on vertical axis, w is the width and h is the height. For x, y, w, h in faces. So we are going to iterate for all the values here. Whatever the values we have obtained here, we are going to iterate all those. Now for this, we are going to draw a rectangle around the face. So one method is there which is cv2.rectangle, which helps us to draw the rectangle. Okay. Now here we need to pass image on which we want to draw a rectangle. Then you have to pass the start point. Start point is x comma y, and end point, you also need to pass the end point. This is my end point, x plus w and y plus h. X plus w means it will draw a rectangle till the last point. So if my x is 0 and width is 3, then it will draw a line from 0 to 3. Okay, so this is the first point, this is the last point, and you can give color to your rectangle border, and also you can define the thickness of the rectangle. So let's give thickness 3. Okay, now the next part is I'm also going to do face detection. Along with face detection, lip detection, that is smile detection, and eyes detection. Okay, so for that, now I'm going to create a 2n dimensional array. So my region of interest, is lips, that is smile, and eyes both. For lip or smile detection, color information is important, but for eyes detection, color information is not that important. So we are going to create a 2 n-dimensional array. One will contain the coordinates for grayscale image and another will contain the coordinate for color image. So let's create 2 n-dimensional array. Region of interest gray, and here it will contain all the coordinates. Okay. So this is the range. This is the range function. So this is from y to y plus h, from x to x plus w. Okay. Then next region of interest. Now for color. Okay. Now this is code ready for face detection. Now let's do for eyes detection. For eyes detection, again you need to use one method, which is eyes, which is equal to I dot detect multi-scale. So detect multi-scale is a method which is used for detection of eyes as well as face. But what we are going to pass here we are interested in only the gray image. Okay, so that's why just copy paste this and pass all these coordinates, this array here. Then again we are going to create one for loop. In whatever the parameters we have obtained here, we are going to iterate them now. And let's draw rectangle around eyes. So here region of interest, comma, we will pass the first coordinate, that is ex comma ey comma last coordinate ex plus w comma ey plus h. Then we will set the color, we will use different color, and also thickness. Okay, now with the help of this code we will perform eyes detection. Now we want to perform smile detection as well. The code is quite similar. Smile dot detect multi-scale and pass region of interest, but here we are interested in color image. Okay, so I'm going to pass these parameters. Again same thing we have to do. Let's iterate all the values. In now draw rectangle around lip. Okay, I forgot to write here region of interest gray. Okay, and here region of interest is color. Then again the first parameter, which is s x comma s y, and then the last parameter sx plus w comma sy plus h, and then set the color comma 0 comma 255 and set the thickness. Okay, so with the help of these 3 lines we can easily detect the smile. Okay, now let's create one window in which we can see the output. cv2.imshow. First give title to that window, which is face, smile, eyes. This is the title, and let's pass our input image, and then finally we will write the termination logic. Until the key is pressed, if k is equal to 27, break. And finally, we will release video capture. This object we will release, and we will destroy all the windows. Okay. Now let's review our code. So here it should be image, not color, and EH should be SW, SH. Okay. Okay, now let's try to run this code. We can also change the thickness. Let's make it 3. It's showing some wrong output. There is some mistake. Let's try and figure out. Here it should be EW. Okay, run it again. Okay. So in this way you can create face detection, lip detection, that is smile detection, and eyes detection. And there are different cascades which are available in OpenCV. You can try that as well. Rename this file. So what we did, we imported libraries. First step, load the classifier, initialize camera, then read your video input or read from camera, convert that image to grayscale, and just use detect multiscale for face. Then whatever the parameters which you obtain, draw a rectangle around the face and just create 2 n-dimensional array, one for gray image, another for color image. And for eyes, in detect multiscale, pass your region of interest, scaling factor, and thickness. Similarly, create a for loop and take this parameter to draw a rectangle around the region of interest. And same, you can repeat this step for smile. And then finally, IMShow for the output, and cv2.wait key to terminate the program and release all the video and destroy all the windows. So this is how you can implement face detection, lip detection, and eyes detection.